Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadli. So now we will go to the introduction of our group project. Our group project is focusing on enhancing KeLIP UNISA into KeLIP 2.0. KeLIP is knowledge and e-learning integrated platform which is used daily by the UNISA students to access academic information such as subject enrollment, assignment tracking, test schedules, exam results, and lecturer announcements. This enhanced version of KeLIP is designed to support the university's digital transformation initiative by providing a centralized, user-friendly platform for both students and academic staff. The key features of KeLIP 2.0 include user authentication, subject registration, real-time notifications for assignments and exams, submission tracking, academic performance monitoring, and a built-in chat feature for student and lecturer interaction. The system will be developed using an agile methodology or called Scrum model, which allows for continuous improvement and responsiveness to feedback throughout the development process. The phase include planning, design, development, testing, and deployment.
Next, I will explain the cost estimation for KeLIP 2.0 project. To ensure accuracy and reliability in budgeting, we applied several estimation techniques. The main technique used was bottom-up estimation, where we calculate the cost of each task and the component in detail based on our work breakdown structure. We also use expert judgment, relying on experience from previous academic system development project. Additionally, parametric estimation was used by calculating standard unit cost. For example, multiplying 3,000 ringgit Malaysia per module by 15 modules, which give 45,000 ringgit Malaysia. To improve realism, 3-point estimation was considered to reflect best case, expected case, and worst case scenario. Lastly, top-down estimation helped in the early stages to provide a face level cost overview. The table on the slide shows the estimate cost breakdown. Key items include 20,000 ringgit for a project manager over 5 months, 30,000 ringgit for 2 Flutter developers, and 7,500 ringgit for UI UX design. We also include 2,400 ringgit for Firebase hosting, a one-time cost of 3,000 ringgit for tools and software, and 4,000 ringgit for QA testing. Finally, we added 10% contingency reserve amounting to 6,690 ringgit Malaysia to cover over unforeseen risks. Altogether, the total estimate cost for KeLIP 2.0 is 73,590 ringgit Malaysia. This comprehensive and multi-method approach ensure that our budget planning is both realistic and aligned with project goals. Moving on to cost budgeting for the KeLIP 2.0 project. Once the total cost was estimated, the next step was to distribute that budget across the project timeline. This ensures that sufficient funds are available during each phase of development, helping to avoid delays or resource shortage. Cost budgeting involves 3 main activities. First, we assign cost to each project phase, from planning to maintenance. Second, we set aside a contingency reserve to handle unforeseen expenses. And third, we allocate the budget based on key deliverables and project milestone. As shown in the table, the largest portion of the budget's 45,000 ringgit is allocated to the development phase, reflecting the efforts required to build all 15 modules. The planning phase is allocated 5,000 ringgit, followed by design with 8,000 ringgit and testing with 6,000 ringgit. Deployment is budgeted at 2,000 ringgit, and finally we allocate 7,590 ringgit for maintenance over 12 months, which includes updates and hosting. Altogether, the total budget remains consistent with our cost estimations at 73,590 ringgit, ensuring a clear financial roadmap throughout the project's life cycle.
Now, I will present about cost control, where we apply earned value management or EVM to track our project financial health and performance. EVM is a powerful technique that helps us measure how well the project is progressing in terms of budget and schedule by comparing planned work versus actual work. Let's look at the key figure. First point is plan view or PV. It's the budget cost for the planned work. In our case, that 44154, which represents 60% of the total project budget of 7,359 ringgit. Second point is earned value or EV, is the value of actually complete. We complete 50% of the work, so EV is a 63795 ringgit. Now the third point is actual cost or AC. AC is how much we have actually spent so far, which is 45,000 ringgit. Now, using this number, we calculate a few important performance indicators. First, we calculate a cost variance or CV. The formula is EV minus AC. That's 36,795 minus 45,000 ringgit. It gives us a negative 8,205 ringgit. A negative CB means we are over the budget. Second, we calculate a schedule variance or CV. The formula is EV minus PV. That's 36,795 minus 44,154, which equal to negative 7,359 ringgit. This shows we are also behind the schedule. For the cost performance index or CPI, we divide by EV by AC. That's 36,795 divide 45,000. It giving us a CPU of 0.82. Since it's below 1, it confirms our project is over the budget. Similarly, the schedule performance index or CPI is EV divided by PV. That's 36,795 divide 44,154. The resulting in a SPI is a 0.83. Again, since the SPI is less than 1, we progressing slower than the plan. To manage this, we use tools like Jira and Excel to regularly monitor the progress and spending. This tool help us detect the variance early and take the corrective action when needed. We also enforce strict change control procedure. Any request for budget, we review by the project manager before being approved. This is because to maintain the financial discipline. In a summary, while project is currently over budget and behind the schedule, the use of AVM and regular monitoring has provide us with a clear insight to guide better decision making to moving forward. Thank you.
The project overview, duration 5 months, budget at completion BAC RM 73,519, land value per month RM 14,718, land progress at month 3 60%, actual progress at month 3 50%, actual cost AC RM 40,000. Actual cost breakdown. The total cost per up to month 3 is 40,000, with major expense going to project manager RM 12,000, 2 Flutter developers 18,000, UI UX RM 40,000, Firebase and software fully utilized contingency reserve RM 3,500. Let's now go through the EVM calculation. EV earned value 36,795, CV cost variance RM 80,205, SV schedule variance RM 7,359, CPI cost performance index 0.82, SPI schedule performance index 0.83, EAC estimate at completion RM negative 89,743, VAC variance at completion RM negative 16,153. Here are summary of our performance metric. PV plan value RM 44,154, EV earned value RM 36,795, AC actual cost RM 45,000, CV over budget negative 8,205, SV behind schedule negative 7,359, CPI poor cost efficiency 0.82, SPI schedule lagging 0.83, EAC highest than planned 89,743, VAC expected overrun negative 16,153. Final interpretation. The key findings are the project is over budget with a CPI of 0.82. The project is behind schedule with a SPI of 0.83. If current trend continue, we expect a cost of overrun of RM 16,153 by project end. Recommendation. To address this issue, we propose optimize Firebase usage to reduce backend hosting costs, replace underused premium tools with free or open source alternative, implement automation in development and testing to boost speed, review team velocity monthly, and relocate tasks to match strength and availability.
As mentioned earlier, our cost performance index or CPI was 0.82, meaning the project was over budget. So we took 3 major steps to improve the situation. The first step is identify unnecessary costs. So we analyzed all expenses and found several issues. So one of the issues is Firebase was not optimized, causing excessive read or write costs. Next, some paid design tools were rarely used, and the most important, manual testing will slow down progress and increase labor costs. The second step is implement cost reduction measure. So next we apply several strategy. So we switch to open source tool to replace underused premium one. Next, Firebase operation were optimized by reducing unnecessary database calls. Next is testing was automated using Flutter built-in testing tools, and we control overtime hour to manage developer cost better. And the step 3 is recalculate CPI after optimization. So after implementing the improvements, the actual cost for AC dropped to 40,000. The earned value EV remained at 36,000
795. So the new CPI equal to EV over AC, which is 36,795 over 40,000. So we get 0.92. So this shows a significant improvement in cost efficiency, bringing the project closer to budget.
Conclusion. Based on the analysis using Earned Value Management (EVM), the KeLIP 2.0 project is currently facing both cost and schedule challenges. At Month 3, with only 50% of the work completed, the project has already incurred about Rm45,000 in expense, exceeding the planned budget for this stage, which is Rm44,155. The cost performance index (CPI) of 0.82 and the schedule performance index (SPI) of 0.83 indicate that the project is over budget and behind schedule. If this trend continues, the final estimated cost (EAC) may reach Rm89,743, resulting in a budget overrun of Rm16,153. To address this, the team has proposed optimization measures such as reducing unnecessary Firebase operations, replacing premium tools with free alternative, and automating testing processes. These actions are a conclusion. Based on the analysis using Earned Value Management (EVM), the KeLIP 2.0 project is currently facing both cost and schedule challenges.